Okay, in the last few sessions, I explained item response theory models, the unidimensional item response theory models for dichotomous and some polytomous item response models. Uh, uh, we talked about the way that parameter estimated, item parameters estimated, and today I want to explain the way that we should evaluate the model. Uh, Actually, the criteria for model evaluation in so many statistical models, including the item response theory models, are fit statistics. So the model, uh, each items of the test and the whole test should be fitted to the item response data. Uh, in this session, I just want to explain how you investigate the goodness of fit of the different unidimensional item response theory models. So the data may be uh, uh, the LS87 data, as I explained before, are let me retrieve some data from LTM. Um, the data, raw data is the LS80 law school admission test. It is a 5 items test scored in a 0 and 1 in a binary manner. So let the data be the LS80 raw dataset. So the data is a 5 items low school admission test. I'm going to feed the rash model to this data. Let's execute this uh, syntax. Uh, if I just named this syntax rash feed, I use mirt. If I actually run it, let's say, let's just first I call the mirt package from the library, and then I can run the syntax like this. I just use the mirt function. The data is the LS80 data. I just defined the data here in this line of the code. So the number of dimensions should be specified here. I'm going to run a unidimensional model, so a single number. Here tells the package that the model is a unidimensional model. The item type uh, tells you which model uh, you prefer to run. I prefer the rash model, so I'm going to fit the rash model for the LSAT data. Through 81 iterations, the model fitted to the data. So if I want to uh, know the coefficients of the model, I can run this COEF function. So you can see uh, the difficulty measures for each item as the rash model ran here. Just the discrimination parameter is fixed to 1 here, like this, and the difficulty parameter estimated in the rash model. So uh, if I just want to know how well the model is fitted to the data, I can use the item fit function here. If we type item fit, here, you can see that this function is included in mirt function, and the name of the model that I ran is the rash fit. So if I run this, you can see that you can see the chi-square parameter, chi-square statistics for each item with the corresponding degrees of freedom. You can find the significance level of each item that shows whether the item is fitted to the rash model or not. If the p-value is equal, is actually more than, not equal, more than 5%, you can find the model well fitted to the data. All of the items, you can see that all of the items, the significance level, the p-value, the corresponding p-value for the chi-square is higher than 5%. So you can conclude that all of the test items are fitted to the rash model. So let's cheer, it's very good. If a rash model, a simple model is fitted to your data, it's good. You can run the other models and compare the goodness of fit measures of each model to the data. Let's say the 2PL model, the 2PL, two parametric logistic model. Let's say okay, let's run a 2-parameter logistic model for this item response dataset. The 2PL model can be should be typed like this. within a column, 2PL, or you can run a 3-parameter logistic model that we do it. And through this command that we ran before, we just um, uh, copy the 2PL model and paste here like this, and we name it the 2PL model, 2-parameter logistic model. It's also unidimensional as before, and it is converged in 22 iterations. So we free another parameter. We free the guessing parameter. So the guessing parameter should be estimated in this one. Okay. Let's find out what the coefficients of 2-parameter looks like. So you can see that the discrimination parameter and the difficulty parameter actually freed and estimated here. And if you want to know the fit statistics for this item response dataset, we can run the item fit function for the 2-parameter logistic model that we ran here. You can also find that the 2-parameter logistic model is also fitted to the model, maybe better than the rash model. We can uh, compare these two models with the statistical testing. There is a function called ANOVA. If I can run it well here, let's I mean the ANOVA function that is included in the mirt, not the stats. The ANOVA function, we can use the ANOVA function for comparing to these two models. Okay, it's actually yields you a chi-square that compare these two models, the rash model and the 2-parameter logistic model. Okay, so the rash fit model is the first model. I actually put the first model here, and the second to this parenthesis. If I run this, you can find that with the chi-square value and the corresponding degrees of freedom, if you find a significance level less than 5%, it's telling you that these two models is statistically different from each other. But here, the difference is not statistically different. because it's more than 5%. So these models are not statistically different from each other. Hmm? But the rash model is better. Why? As I said before, for finding the optimum model, any kind of modeling, item response theory modeling, or uh, in unidimensional modeling or multidimensional modeling, the simpler model is preferred. The simpler means that the model has less parameters and it's simpler. If you can find a model that is simpler and has less parameters and is not statistically different from the other models, so the simple model is preferred. And rash models, as I said, actually are, and rash models are actually more popular among practitioners in assessment. Uh, you can also, you have also the AIC and SABIC and the BIC parameters, or these are relative fit indices that Bayesian index comparison. This is some relative fit indices that tells you which model is better than the other. The less the lower measure, the lower magnitudes of BIC and AIC indicates the better model. Yes, somehow better than, but not slightly. Yes, it's slightly better than the two-parameter model, and why not? It's better. It's not significant as you said, but it's better because we have less AIC and BIC parameter. When you want to write a paper, an article for actually finding the optimum model for some data sets, you should report all of these measures, the uh, relative measures and the absolute measures. The item fit statistics uh, showed here are the absolute measures. They are telling you whether the items are fitted or not. And the the relative fit measures are AIC and BIC. These are relative. You cannot find from the absolute measure magnitudes of these uh, measures to find out whether the model is fitted or not. They just tell you which model is better. Not it. You it's the BIC and AIC measures are some global actually relative fit measures that are used in different statistical modeling. A model relative to the other model. This is the relative. So first, we're finding a better model. We use the relative ones, and then when we got our model, we get to the absolute ones to see if that model is fitted or not. Yes, we do actually in modeling, in assessment modeling, we uh, fit different models in item, either in item response theory modeling or in cognitive diagnostic modeling. We run different models, and then we actually run the fit measure, the relative and the absolute fit measures to find the optimum model. You should find optimum models for your item response data. There is also, if I'm not wrong here, We have also a absolute fit measure for the whole test called M2 model fit statistics. It's actually referred to the uh, Madio, Livers, and Joe 2006. This statistics is when all data are dichotomous, like here. It is a chi-square based statistics. You can run this for our model for the total test. For example, for the rash model, let me run this for the rash model. Uh, uh, M2 chi-square based statistics with the corresponding degrees of freedom gives you a p-value that if the p-value is more than 5%, so the whole test, not each item. We have fit statistics for single items, and we should give some uh, measures for the goodness of fit for the whole test, for all of the items, for the whole test, for the whole measures. The M2 measure with the corresponding degrees of freedom yields you here a p-value about 0.81, so it's more than 5%, and the model is actually fitted to the whole data. We have also some uh, uh, absolute measures like RMSEA that is so popular in statistical modeling. We have this measure. It stands for root mean square error of approximation. You have also this measure in structure equation modeling. You have also this measure in cognitive diagnostic modeling. It's an absolute measure for goodness of fit. So the measures less than 8% is mm, desirable. Less than 8% is desirable. Here it is not zero, it's about zero. It's RMSEA. It stands for uh, root mean square error of approximation. Let me just, it stands for root mean square of root mean square. Uh, here, error of, and A for approximation. Approximation. I just write it somehow different. Okay, it's no. If you head like Ramsey, it's RMSEA approximate. Uh, so you have also SRMSR. It is also, if it is about zero, you have also this measure for other modelings like structure equation modeling. And you have, it should be about zero. You have also TLI and CFI. that should be more than 90%. It's about it's close to it should be more than 0.9. Okay. Uh,
Only simplified about the read this in the previous semester. We had quantitative research. We somehow worked with species and limited access, of course.
uh-huh,
We were introduced by the CFI, RMSA, and
uh-huh,
squares.
uh-huh.
So we know the terms, but specifically and practically, we have wrong them. So what was CFI about?
Uh, these are also these all measures actually. I just um, calculated these measures for the two-parameter logistic model. You can see that the two-parameter logistic model is also the whole test is also fitted to the model, but you can see that here is also indicating that the Rash model is mm, somehow better than not statistically, but totally is better than the comparative fit index. You can see, yes,
It compares two models.
yes. These are also these are absolute fit measures. You know, we can talk about fit measures uh, in a sense that these measures that you see here are something that uh, is somehow mathematical. It's about a matrix, a residual matrix, that if the residual matrix is about zero, the fit measures that derive from the residual matrix is better. So what's the residual matrix? You have a observed matrix and you have a reproduced matrix from the model. The reproduced matrix is about the model that you fitted to the model. If the model is good fitted, well fitted to the model, to the item response data, so the reproduced elements of the matrix is uh, actually close to the observed matrix, to the initial uh, observed matrix. So the residual is about zero. And if the residual matrix is about zero, the fit measures would be better if these two matrices are close to each other. It's the definition of the yes, yes. You have these measures also in structural equation modeling. In the structural equation model, the conceptual model is based on the theory. And if the theory is well fitted to the covariance matrix, the covariance matrix is actually the representative of the measures that you have done, and the reproduced matrix is about the model, the conceptual model that you fitted to the item response data. So is the theory, if the theory is sound and well, so the reproduced matrix element is close to the uh, close to the initial matrix, initial covariance matrix is same in a structure equation model. So the difference would be close to zero. So it well fitted. So the fit is about these two matrices, the initial matrices and the reproduced matrices. So if the elements of the matrices are close to each other, the model is well fitted. No? You may want to just do the same for the 3PL model. That is the three parameter logistic model that the guessing parameter is also free to be estimated. So you can run the three parameter model. We just change this to three parameter model and we name it 3PL with the same syntax. Is also run with 28 iterations. If you want to find out the parameters, you can run the COEF function here like this. So the guessing parameter called G here and is actually estimated.
Higher than 0.5 is optimal.
0.5? No. The guessing parameter is a measure between 0 to 1. It's a probability, just as simple as that. So the guessing parameter for the first item is about 0.06, and as follow for the item 2, it's 0.17 about it for the third, and for the fourth and the fifth item. You can see that the guessing parameter for the second and fifth item are uh, somehow more than the other items. Um, you may want to compare these three models. Let me run these three models to see whether these three models can be actually compared simultaneously or not. I didn't try it. Let me just try here whether I can. Typo. You can see that more than two models can be simultaneously compared to each other, and you can find the AIC and BIC models here.
So these are relative.
Yes, these are relative fit measures. So still you can see that the Rash model is the good choice for uh, this kind of model.
Based on BIC. BIC and
BIC, AIC, even the SABIC are all, even
lower.
the HQ is also a relative fit measures that is new.
What is HQ?
It's just a relative fit measure, not important. Like
So we don't need to what they stand for.
it's the lower is the better.
The lower the better.
It's a measure, maybe somehow actually uh, in the logic that stands behind all of this is the same. The lower is the better. Okay. Oh, as I said before, the model that if you run the ICC or item characteristic curves plots for the test items, you can find uh, how the curves would be, and if it is S-shaped, it is more fitted to the model. S-shaped, I mean the letter S, the curve. Let me show this. If you run the plot function for the models, you can, it is a curve that you can compare this to the M2 statistics for the whole model. S shape, S like S. It's a logistic, so a logistic curve is S shaped. If it is more S shaped, it is more fitted to the item response data. Okay? You can also uh, try the other models. This is for the two parameter model. You can actually, you can see that the rash model is more S-shaped than the 2PL model. So as I said, it is also true for the single items. If you plot the single items, as I ran in previous sessions with the mirt function, you can find that the more S-shaped plots are better fitted to the model. Let's try the 3PL model. Like this. So you can see from these three item characteristic curves, it's actually test characteristic curves because it's the a curve for the whole test. It is the vertical axis is the uh, total test score, and the horizontal axis is the ability axis. Actually, it's continuum for the ability. Uh, 0 is the average ability, less than average is negative, and more than average is positive. Good for today. Any question? You can run these commands and the other models home. You can also do this for the polytamous items, Likert types item response data. You can also find the goodness of fit measures for, yes. The rash model is also uh, used for SQL analysis, the rating scale or the Likert type